Okay, so now let's look at another way to solve this. I'm going to do a similar example, not the exact one from this edition, but I'm going to do one from a previous edition because I think it illustrates this a little bit better. We're going to integrate here, and I'm going to put dx over 1 plus cosine x. Okay? If there's a dx on top, you know that's just saying the same thing as 1 over 1 plus the cosine x dx. Now our every single time go-to method is always going to be a u sub. But is there anything I can u sub here? Not really, right? The only thing I could really do is 1 plus cosine x. That's not going to help, right? That's not going to help me whenever I try to do a du. I don't have another sign to put in there. Okay. So that's not going to stir the Kool-Aid. If that's not going to work, then we get creative with our algebra. So with our algebra now, I'm going to take this and I'm going to multiply by a 1 minus cosine x over a 1 minus cosine x. As long as you multiply the top and the bottom by the same thing, it's legit. All right? So that's totally legit. All right. So, and the whole purpose of why I do this is anytime you have trig, start thinking about what are things we know with identities. So what's a relationship that I could work kind of with a cosine and a 1? Yeah, that Pythag identity, right? Sine squared x plus cosine squared x is equal to 1. Let's see, is there something I can work with there? That's what you want to go with. Well, whenever you multiply here by this conjugate or the difference of squares, right? Because this one's plus, this one's minus. Then I end up with 1 minus the cosine of x. When you FOIL this out, it's just the difference of squares, right? Square the first term minus square the second term. Don't forget your differential. I'm going to be crazy on you about this differential. And I'm crazy on you about it right now because in Calc 3, you are going to have multiple differentials because you're going to have multiple integration. So get used to writing it now because I know where you're going with this. All right? Okay. So now I can look at this. I cannot cancel out these cosines because of this minus sign. It's bound together. You can't do that. So it has to stay just like that. However, you can rewrite this identity to say sine squared of x is 1 minus cosine, right? So I could sub that in. And anytime you get a monomial in the denominator, it's awesome. So my goal, if you can, is to get that monomial in the denominator. Monomial just means single term. If I get this monomial, then I can split it up. So a single term in the denominator, that's the concept of fractions, right? If I get that common denominator, then I can split that up. So what I actually have is 1 over sine squared x minus cosine over sine squared x. And now we use identities. What's the reciprocal identity of sine? Cosecant, good. So this is cosecant squared x. Ooh, it's looking good, right? Because we know that antiderivative. If I split off one of these cosines, like that, right? A cosine with a sine and then one sine that's left over by itself. That's going to give me my cotangent cosecant. And that's awesome too, isn't it? Because that's also an antiderivative. Good, you guys, good. So cosecant here, the antiderivative of cosecant is negative cotangent. The antiderivative of cotangent cosecant is negative, so this minus, and I have cosecant x, but it's a negative, which is what makes that positive. And that's our final answer. So here's the defining characteristics. I told you I'm going to use these words all the time. The defining characteristics that go with this. I have a cosine. I cannot do a u sub. There's nothing else around that can pull this off. So because of that, I am going to see what kind of identities can I work with. I've got the Pythagorean identity. And with that Pythagorean identity, then I can algebra this down. All right? That's what we're looking for. Things that you can do to manipulate these. Okay.